I hope you are doing well. And like I have already uploading the answer of all the questions that I have posted yesterday on my status. Now this is one of them. This is one of the crucial problem that many students committing mistake in that. So let's discuss this problem and trying to solve so that you can avoid those mistakes that maybe you commit once it will come in your examination. So the question is MA and MB, their respective masses are 2 kg. 1 kg block is moving with 9 meter per second collide. Now here you can see 9 meter per second collide with B and get stuck into it. What do you mean by get stuck into it? Means it will be inelastic collision. And once the inelastic collision, the whole mass system will become 3 kg. Whole mass system becomes 3 kg. Calculate the height reached by B during the subsequent motion. Now here we can say once the 3 kg and B block will get stuck with each other, so they will start moving upward direction. Fine. So if you can see, once they are moving upward direction, so there is some free fall motion is going to be take place. So what will happen? Let's say they together move distance h. So since it is frictionless pulley, so the B will also, Miss A will also go by same distance. Like if it will be slackened, so same height, the string will be released, and in this way, let's say A has also moved down by the same length. The length that got slackened from B, the same length, the A will also move downward. Fine. So this is the situation one, and what will happen afterward when both will be, you know, once the B will be releasing the length, same it will be acquired by A. So both will become taut once again, and there's a common motion of A and B taking place. But once B will be reached to this height and A will go simultaneously, so there's a jerk going to be take place. For the sake of that jerk, the block, both block get jerked, and since A is moving downward direction, so it will surely continue the motion. But since mass of A is less than mass of B, so we can say once A and B moving together, there's some common acceleration. So here we can say that is a retarding motion. A will go, let's say, some height h2 dash, and let's say h1 dash. B further move h1 dash, and then since mass of B is more, so it will going to be stopped, and then a reversal of the motion take place, and then the B will start moving downward and A will start moving upward. So this is the whole situation of the problem. Now let's take up one by one and solve. So let's quickly do. This is the situation like once it will embedded. So basically we can use law of conservation of momentum. Now here you can see law of conservation of momentum. M initial, this is the initial momentum. Initial momentum V was 0. That is equal to the final momentum. Both will moving with common velocity. And since mass has no impulse, that's why we have not taken any impulse over here. So we can get the common velocity once the impact will be done, and then it will start moving the way I told you. It will moving, let's say, some h1, same h1, it will move downward under the gravity. This will be free fall actually, because once it got hit, the string got slackened, and once the string got slackened, it will be released to A. So under this situation, we can say the motion will be done under gravity. So let's calculate what is the h1 height. It will be traveled by 3 kg by initial velocity 3m, and since b velocity is 0, so it will free fall. So let's make a equation. Now here we can say h1, that is ut minus half gt square for b block, and that is equal to half gt square for block A, since block initial velocity a was 0. So by this way we can get how much time once again taken by the string to once again become taunt. So here we can say, like, it will take, because after impact the string gets slacked, fine. So after 0.3 second, string become taunt. String become taunt once again. I thought you are getting the point. Now during this zero point 0.3 second, what is the height gained by the block? We can calculate h1 very easily. That was 9 by 20. That is the height attained by either B, or it will be fall down by in the next block A. So the three, what will be the velocity after traveling this much distance? So here the 3 kg V is equal to U minus GT. So V minus GT, so that will be 0. Is after traveling this much distance, it will look like the final velocity becomes 0 of 3 kg. And what will be the final velocity of 2 kg? It will be 3 second after 0.3 second. So here we can say velocity get swapped with each other. Since 3 kg velocity is 0, so it will momentary at rest. And since 2 kg is moving 3 meter per second, for that momentum, we can say this is the moment where the impulse will come into play. So there's a jerk take place that will take the block 2 kg downward direction and 3 kg in upward direction, because here they will stop, but suddenly impulse start acting. So further motion take place, uh, and 2 kg start moving downward with some common acceleration, let's say. Fine. So now here we can say the impulse acting in a 3 kg, let's say the along motion direction we can consider plus, and against the motion we can consider with minus sign. So this is the motion direction. That's why T into dTA, that is impulse, that is equal to change of momentum. Let's say the final velocity is 3 mv and initial velocity was 0 for 3 kg, and for 2 kg we can say, actually this is a motion direction. If we consider this motion direction plus, to upward it will be minus. That's why minus T into dt, the impulse acting upward direction, that is a change of momentum. So final velocity it is V, to 2 mv minus 2 into 3. Fine. This is the initial momentum actually. So now by using these two equations, we can get the velocity V1. The velocity V1, that is 6 by 5. So this is the velocity after having taunt, they start moving upward direction. So that means the block 3 additionally travel some distance h, let's say h2. So what distance it could be? We can calculate very easily, because initial velocity, like once from v is equal to 0, it will further travel. Like once the impulse will be there, the velocity will convert into v1, and once again v1 going to be 0 at some instant of time, because 2 kg and 3 kg once they are moving together. So this is a like a retarding motion here. Retarding motion means block 2 will start decreasing its value and uh, likewise 3 kg as well. Fine. So here we can say once we calculate the common acceleration, so actually it will become common retardation once the string get torn. This is the common retardation we can say, like you know very well, m1 minus m2 upon m1 plus m2 into g. So that will be comes out to be 2 kg. Which from this position to some h position, the block will start moving with initial velocity and the final will be zero, of course. We can calculate 3 kg block, the additional distance it cover after common, common acceleration or common retardation. The final velocity it will be zero. V square is equal to u square minus 2 as. Fine. So s, that is h2. Acceleration we have calculated. Initial velocity we have already calculated. Fine. Initial velocity we have already calculated. That was 6 by 5 for the sake of impulse momentum conservation. So here, what exactly happened? H2 will become additionally. So here we can say the first instance when the what hit it and turned to zero, and the second instance once the common velocity and retarding motions that will going to be take place. That's why these two will be added. So answer will be 0.0821. Majority of the students they have overlooked the second part. That's why please understand the constraint of motion, because once the constraint got cleared, so you can do the problem very easily. So please remember, in this case, uh, two height it will be attained by the block. First height got slack. Once the string get taut, and when the taunt, since unfortunately 2 kg move, then that's why the retarding motion take place, and it will going to be stop after a while too. Here we can say H2. So H1, H2, these are the two specific height, and majority of the student they have not calculated H2. So please note this point. Till then, take care, and I keep posting and keep updating you. Please stretch yourself. Take care. Bye bye.